So here we have SRX active-active cluster. We have two SRX connected and pre-configured with a chassis cluster. And here we have one SRX as a primary and other as a secondary. And this topology is a design in a way that it has a high fault tolerance even on the VM level. So we have Windows 2019 based server, and these servers have NIC teaming configured with their respective default gateways. Okay, now let's verify the interface IP addresses. So we can see that the three RETH groups are configured and their respective IP addresses. Okay, now we'll verify the chassis cluster configuration where we can see the primary and secondary. So the node 0 is a primary here, and preempt has been configured on RG group 1, 2, and 3. Now let's verify the interfaces. The interfaces are configured with the weight, and you can see they are all configured with weight 255. The fab links are up. Right, now we will verify the VMs, the VM settings with the NIC teaming configured, and we'll verify the ping to their respective default gateway. So this is our server 1, and we can see the IP address and the default gateway. Okay, now let's verify the teaming, and the teaming has been configured with both the links enabled, and now we'll ping the default gateway. So we got the ping successful. Likewise, we'll verify the server 2 and the server 3. Right, so we got the ping successful from all the servers. Now to check the redundancy, what we will do is uh, we'll start the continuous ping from server 1 and server 2 towards server 3 IP, which is 10.0.0.10, and then after doing the continuous ping, we'll try to failover redundancy group 2. All right, so ping is fine. Right, let's go to the primary SRX CLI. Here we can see the interface 005 is up, and this is the primary interface for my RETH group 2. So we will disable this interface, and while this interface is being disabled, we will monitor the ping at the same time, so that we'll try to find out how fast the failover happens to the secondary SRX. All right, so after commit, let's see. It's now committing to node 0, and node 1 is completed. So okay, so it took only one ping drop, and the traffic continued. So the data plane is now failed over to the secondary, and now let's verify the chassis cluster status, and we can see that the redundancy group 3 has been failed over to the secondary. Right, so it is successfully moved to the node 1. Let's verify the interface status. So the interface G005 is showing down, and the respective 7005 secondary interface is up. So now we can verify this using the Wireshark, and Wireshark will help us identify the actual traffic flow. So the server 1 and the server 2 will send the traffic to primary SRX because the data plane is active there, and then via the fab link it will reach to the secondary SRX, and from there it will finally reach to the server 3. So here let's see if we can see the ICMP replies, and yep, so we can verify that we have the traffic on this link. And when we verify the link G005, so there won't be any ICMP traffic, as it's already moved to the secondary SRX. All right, so here on this link we don't see any ICMP, and we can ignore this virtual link traffic. So at this stage, the link redundancy works fine. Now let's roll back the disabled interface, and that will immediately move the traffic to primary, as we have the preempt enable. So let's commit this, and we'll verify. All right, so it's committing, and we are monitoring the packet drops. So there is no packet drop so far. And we can see at the back, the moment the commit completed, the traffic is stopped on the secondary link and immediately it switched over to the primary. Okay, that's all in this video.